this video, we're going to start off with a very simple problem from the statics textbook, chapter 2 from Hibbeler. So we're given all three forces in this problem. Suppose that F1 equals to 850 newtons, F2 equals to 525 newtons, and F3 equals to 750 newtons. We're asked to determine the magnitude of the resultant force in part A. In part B, we're asked to determine the direction of the resultant force measured counterclockwise from the positive x-axis. So in chapter 2, you'll see quite a few problems asking you to determine the magnitude of the resultant force, as well as where that resultant force is going to lie in this xy plane. And in the next slide, I'll be sharing how to solve this. So most of you like to start off with drawing the free body diagram for this problem, but I actually like to set up the template first. So template meaning that what are my equations that I'm going to be using. So I know that I'm asked to determine the magnitude of the resultant force. I know the equation for the resultant force in a 2D problem. So resultant force equals the square root of the resultant force in the x direction, so Frx squared, plus the resultant force in the y direction, square. Then I'm asked to give the direction of that resultant force. And I know that theta equals to inverse tangent of Fry over Frx. So I know those equations. So you see here, this will go on the top, this will go on the bottom. Now I'd like to draw the free body diagram. So let's draw very badly the x and y plane. Okay. Y, x. And I know positive x points in the right direction. Negative x goes in the left. Positive y is pointing upwards. Negative y points downwards. And I'm sure you already know this from your previous math classes, but I like to draw it out to remind myself, because sometimes, and also a lot of students, get the signs wrong. So let's draw the forces. So F1 is given to us as 850 newtons. And I'm sure you've seen this in quite a few statics problems, and some of you may be confused, but let's draw it out. I know I was very confused with how to work the statics problems with triangles, but I'll go over that in a little bit. So F2 is 625 newtons. Sorry about that. I know you are probably trying to read my handwriting. And pay attention to this. Okay, this angle is measured from the y-axis, which is 30 degrees. This also used to trip me up. F3 is pointing upwards. Let's write that in. And that's given as 750 newtons. And it's also measured from the y-axis at 45 degrees. Okay, so now we got our equations, we got our free body diagrams, and the next thing I would like to do is try to solve the resultant force in the x direction first. But what I like to do is I like to break these forces into their x and y components. So let's start off with F1x, okay? So you know that typically the forces are 625 newtons times, cosine or sine of that angle. Um, but we have this triangle here, okay? So let's write it out, 850. So we like to multiply this by 3 over 5 or 4 over 5, depending on which component you're using. So in the x direction, we use this line that's parallel to the x-axis. Okay, so we're going to write down 4 over 5. Okay, f2x, okay, is 625. Okay, but remember, it's measured from the y-axis, so it's going to be sine 30. And I also forgot to mention the positive and negative signs for these forces. So this force is pointing in the positive x direction. Okay, so this is going to be positive 850. Okay, now this f2x is pointing in the negative x direction, right? So this is in the negative zone. So we're going to put minus 625 sine 30. Moving on to the last component of x, okay? We're given 750 newtons. So 750 times, and again, measured from the y-axis. So that's actually going to be sine 45 degrees. Okay, and that's also negative. Hope you're following along. We're going to do the y direction next, and I'm going to put it side by side so you can see and compare it. Okay, so f1y, okay, 850, okay. And remember, we're taking the side of the triangle that's parallel to the y-axis, which is going to be 3 over 5. Okay? And where is it pointing down? It's pointing down. Okay? The negative y direction. So we're going to make this a negative. Now, f2y, okay, is going to be 625. Now, we had sine 30 in the x component, but in the y component, we're going to do cosine 30, and it's in the negative y direction. So we're going to do negative here. Okay. The last component for y is 750. Okay. Remember, we measured from the y-axis for the x component. Okay. So we're going to do 750 cosine of 45 degrees. Okay. So we're going to add these up. Okay. So let's see here. I'm going to add these up. Add these up. Okay. So we're going to take a look at my calculations. And so the x is going to be negative 162, okay, 0.83 squared. Okay. Now this is going to be negative, looks like 520.94 squared. Okay. So we're going to plug that into the resultant force equation. Okay. We're going to square root that. Okay. Plus 20.94 squared. And that's going to equal to 546 newtons. And that's the resultant force. Okay. But again, you also need to show the direction of that resultant force. Okay. So we're going to plug the resultant force, in the y direction, which is negative 520.94 over negative 162.83. Okay. These signs cancel out, so that's going to be positive. And that angle, okay, is going to be 72.6 degrees. Not quite yet, because it's asking you for it to be measured from counterclockwise from the positive y-axis. Counterclockwise from the positive x-axis. Okay, so you're going to add this, okay, 180 plus 72.6 degrees. Okay. So I'm going to use this dotted line here to show that this is the resultant force. Okay. This is measured 72.6 degrees here. Okay. So let's call this angle B. Okay. And you're going to add 180 degrees to 72.6 degrees. Okay. And that's going to be 253 degrees, measured counterclockwise from the positive x-axis. So hopefully that helps. See you in the next video for the second problem. Oh, and let me know in the comments if you have any questions. I'll try to answer them as quickly as I could. Thank you, guys.